Hello, and welcome processing users. My name is John Park. I'm from the Art and Technology program at the University of Oregon. And in this two-part tutorial, I'm going to be looking at the pixels array in processing. I've never been that satisfied with how the pixels array is described in the processing reference, and there are some great tutorials out there by Dan Schiffman and others around this. But I want to use the pixels array in a very specific kind of way, which is to really be able to absorb and take in the individual color information from raster-based images like a JPEG or a GIF or a PNG file, and to use them as a starting point, as important information to make other art pieces. So to do this, I'm going to be starting with a reference file that is just a web icon. It's just of a kind of a folder, right? And specifically, I'm going to know, or rather I should say set the size of this image to be something that I can really remember and understand. So under Tools and Adjust Size and Preview here I have it's set to 256 by 256 pixels. I'm choosing this because unlike a lot of other things you can do in processing, which is very fluid and experimental, and there are kind of many great things you can do with images, when you start to grab pixels from the pixels array, which we'll talk a little bit about more in a moment, it's very specific. It needs to know exactly how big that array is, and it's great to be precise during this type of process. So I'm remembering 256 by 256. In a processing sketch that I've already kind of pre-written here, I've got a very basic image setup where I have this thing called a P image. It's called pick, and then in void setup, so it only loads once, I'm setting pick to load an image and point to that file that we were just looking at, which I've already dragged into this sketches folder. Now, for the sake of doing this tutorial, you don't really need to follow along if you don't want to. But if you do, I suggest you grab an image that's 256 pixels by 256 pixels, just because it's going to make this a little bit easier to understand. All right, so I've set the size there, I've got the picture there, and I'm even drawing the picture, I'm displaying the picture with the image function here in void setup. Notice I do have a void draw, but it's empty, and I'll even get rid of this for now. Okay, so all it's really doing is just drawing an image once at the top left corner. I'll go ahead and hit the play button. And great, there it is. This is a very basic image thing so far. If you've never used a P-image before, you probably shouldn't do this tutorial yet. You should go back and really learn how P-images work and do some more basic image manipulating stuff or kind of functions in processing before dealing with this pixels array. All right, but the main idea at this point is I'm just going to be using this example to explain how the pixels array works. I've got an image in void setup drawn at line 6 here. And I'm doing it in void setup because I only need to load in the pixel information into memory essentially once. And once it's saved into memory, why then I can use it in other places, other locations. Very simply, anywhere in processing where you want to kind of capture that current moment and what all the pixels on the whole screen look like, you could just say load pixels, open close parentheses, notice the capital P. This whole thing should turn blue if you spell this correctly. And this is just going to be kind of this built-in function where we're telling processing, hey, I want you to grab every pixel in your whole screen, in this case 256 pixels wide by 256 pixels wide, grab every single color and save each individual color to a single array. Remember, an array is an ordered list of data. And so, great, I've got all this, this kind of seems right now like an imaginary array of information. From here on out, I can refer to that array simply as pixels. Okay, notice it turns this kind of teal colored blue. It is a built-in thing, but it's not a function. It's something that just now exists. It's an array that exists because I called load pixels. So you have to do this line once, at least, for this to work. Now that I've got that thing called pixels, it is an array. But what's kind of odd about this array, if I kind of were to go to the processing reference page and I were to look up pixels, Maybe I'll look up the pixels example. Here's a nice example that Dan Schiffman wrote on processing.org, the main web page. I'm going to scroll down, down, down. This kind of gets into basic stuff with images and manipulation. But this is the picture that really matters here, okay? We all see JPEGs or images on the internet as being an X and Y grid, a two-dimensional plane of colored dots, and when you stand far away, your eyes optically blend those dots and we see what looks like a sunflower or a portrait or anything else. But we're kind of used to just seeing things as this like 2D spatial plane. Now, what this picture shows is how we might kind of think about how would you count these pixels, right? The normal average person might think of it as an X grid and a Y grid, and so this might be, 3 pixels over in the X and 4 pixels down in the Y, and we might get the color of that pixel. But how the pixels array works in processing is it stores all of these pixels as one long line. And in other words, if you had a tiny picture like this 5 pixel wide by 5 pixel tall image, and let's say each of these didn't have numbers, but they were each individual colors, then we would have 25 total pixels, right? 5 times 5, which determines the shape of the whole image. But what processing would see would not be a X and Y grid of things, because that's kind of complicated for some people to kind of pull things from. Instead, they would just sort of contain all of that data in one long line. So this single row of numbers here is what processing would actually do in the pixels array. They would be numbers 0 through 24, right? Because 0 is always the first item in an array. So as an example of that would be, well, if I wanted to know that color, right, of that specific pixel in this picture, in the pixels array, it would actually be, the 9th item or item number 8 in one long line. The long line of pixel colors, it doesn't care about X and Y grids. It thinks of everything as one dimensional array. Okay, so knowing that, or at least seeing that, let's go back to our processing sketch. I've got my 256 pixel by 256 pixel image. I already loaded in those pixels into this thing called the pixels array. So remember, anytime you want to figure out how big an array is or how many items it has, you could always use the print line to spit out a little message in the bottom. And I want to say, well, pixels, that's the name of the array, dot length. Now, length just means how big is an array, how many items are being held in it. I'm going to hit stop and play. It spits it out once because I asked for that in void setup, which only runs once. And it says, hey, you've got 65,536 items in your pixel array. What they really are their colors, okay? Each item is actually storing a color, which is kind of crazy, right? It's a lot of colors. But there we have it. Now, is that number completely random? It absolutely is not. That number would be the same thing as 256 times 256. Why? Well, that's how you kind of figure out how many things are in an area, right? The width times the height. So that is the total number of colors in the picture. Okay, so that length gets us the total number. What if I want to grab an individual color? Okay, well, if there's 65,000 of them, let's say I want to pull out the 32,000th color, because I know there's 65,000 of them available. I'm going to grab, color numbers 32,000. And let's just see what it says. I hit stop and play. Okay, I run that and it looks like maybe I've hit an error or something, like this is some strange negative number. What's going on? Well, this is kind of an internal way that processing is talking about an individual color. If I wanted to really see this in human readable form, since many of us are used to red, green, and blue, I could say, well, what is the red color, the kind of redness, if you will, of that individual pixel? Remember, that thing in yellow is a color. So I'm saying if that thing is a color, then what is the red value of that color? Okay, I hit stop and play. It says it's 249. That's actually almost 255. So it's saying the color that we chose is almost white. It's like in at least almost fully red. So what I'm really guessing is the number I chose is actually one of these kind of whitish areas around the background. If I were to keep on choosing numbers here, I could probably find a color that's somewhere in this pink range. Is it worth my time, your time, for me to do this on a video? Very questionable. I'll just see if I get a little bit luckier. Oh, there's a slightly lower number. Okay, so that 252, I'm guessing that this is somewhere, I don't know, maybe on the edge, or it could be somewhere that's really bright over here. So because, again, I'm pulling a number out of a long, long line of colors, what it's actually doing is if I were to choose a number that happens to be, in this case, like maybe 14 versus 11, they would give me two very different places on the locations in the picture. But yeah, okay. So that's how you individually grab a single pixel. Okay, so if I can read in a pixel by saying pixels and that, I guess it begs the question, can I write a pixel? Can I change a pixel's color? And the answer is yes, absolutely. Oftentimes, a pixel array is coupled with a for loop if you want to go in and assess every single pixel and either read in values or set values or swap values. All of those are possible. So I'm just going to write a little for loop. For int I equals 0. Okay, I is less than. Here we go. This is important. How big is my for loop? I want it to run as many times as I have pixels. And I just had there a second ago, well, I know how many pixels I have. I have pixels dot length number of pixels. What was that number? It was 65,000 something, right? So that's how many times it will run, semicolon, I plus plus. I'm going to close the parentheses, open a curly bracket, drop down 2 lines, close the curly bracket. Okay, so my for loop looks like it's been constructed properly. It has semicolons. It does not end in a semicolon at the end. That's very important. It does have an open close curly bracket. And I've got a starting value, how long this thing lasts, and then what happens each loop, which I is going to grow by 1. So what could I do inside of this? Well, I want to, let's say, take every 35th pixel and change its color. All right, let's say that was on my master plan of ideas. Okay, so if I have this long, long line of pixels, and I want to grab every 35th one or every third one, right? What I really want to know is the number that I'm looking at, if it was 35th pixel, is each number I'm looking at divisible by 35, right? So 0 or 35 or 70 or 110, you can kind of, did I get that right? 110? 105. You might want to know if I were to divide I by a certain number, would it be cleanly divisible? Guess what? There's a really fancy, not even fancy, a beautifully simple idea in computer programming which can give you just that information. That we normally don't learn in schools, and it's called a modulo. Okay, so what I'm really saying is if I, which is the current pixel number that I'm on, and all you have to do is say percentage sign 35. What that means is if I take I and I divide it by 35, what is the remainder? Okay, what is the remainder? If I took 36 and divided by 35, well, 35 can go into 36 one whole time, plus the remainder is 1 left over. So modulo is really kind of paying attention to what is the remainder of a division. Because I is up to 65,000 something, there are going to be lots of pixels that are divisible by 35, but I don't want to just find out what it's divisible by. I want to know, is it cleanly divisible, right? Is it 35 or is it 70 or is it 105 or is it 140? And the way to really do that is to say, well, if I modulo 35 is equal to the number 0, meaning there is no remaining number. If I divide 350 by 35, it's cleanly going to be the number 10, right? 350 divided by 35 is 10, and there's no remaining numbers left over. So that's good. So if that is the case, then what do I want to happen? Well, I want if I is divisible by 35, I want to reset what I's color is. So I would say pixels, square bracket I. So that would be pixel 0, pixel 35, pixel 70, pixel 105, pixel 140. Just those every 35th pixel. And I'm going to set it to be a new color, equals color. And I'm going to set this to be something really obnoxious, guys. 50, 75, 255. Okay, pretty blue. Okay, so that's going to kind of, this whole for loop now is going to loop 65,000 times. And every 35th pixel, or every 35th time it loops, it's going to set that pixel color to be this bluish, purpley color. Anytime you change a color of a pixel in the pixels array, you have to use the term update pixels, semicolon. You can do this in void draw, totally fine. Pixel arrays are really fast, so it's fine to do this in void draw. But just heads up, anytime you set a new color, you have to do update pixels. All right, let's run this. Boom, look at that. Okay, now, this might not look that impressive to you, but I think it's kind of impressive because we individually went in, we said every 35 pixels, set the color to blue, and because of the way that this image is arranged in the total number of rows, 256 pixels wide is not cleanly divisible by 35, and so what that really means is we end up getting diagonal streaks. If I were to change this to 12 and rerun this, I get more stripes in a grid. But if it were, 17, again, I should get diagonals going in other directions. So we're individually going in, grabbing pixel numbers, resetting their colors, updating the picture. And by saying update pixels, it both takes these new colors into account and then just displays the whole picture for us, which is really nice. Okay, so let me think if there's anything else we really need to bring up with this idea. Yes, there is one more idea. The pixels array at this point, as soon as we say load pixels, the pixels array is completely stored for us. It's stored in memory. It's completely in our program's memory. So what this really means is if you kind of understand that we have this, in this case, 65,536 item long, set of colors in an array, I could actually just comment all this stuff out and just kind of make sure that that load pixels line is in there. And what I really want to do is ask myself, well, gosh, could I say just click on a pixel and reset its color using the pixels array? And the answer is yes. This comes to a really kind of important kind of formula I need you to remember. Okay, so outside of void draw, I'm going to do a void mouse pressed. Remember, this is a function that fires off anytime you click the mouse. And what I really want to do is I want to say, well, gosh, I was just able to reset a color. I want to reset a color, and I'll get back to what the kind of what item in the array is here in a second. But I want to set that color to be bright red, 255, 0, 0. Okay. I also want to, sorry, let me do that. Pixels blank equals color 255, 0, 0. Okay, so that's fire engine red. And remember, anytime you update a pixel or change a pixel, you need to say update pixels. So we're going to put that in void mouse pressed as well. But the real question is, I want to kind of convert my mouse click, and processing pays attention to our mouse location as mouse X and mouse Y. But shoot, how am I going to do that, right? Because look, the pixel array stores everything not as an X and Y grid, but as just one long line. So is there some fancy built-in way to kind of get essentially an XY grid equivalent in a long line of these pixel numbers? And the answer is actually yes and no. What's really, I think, a better way to think about this is to memorize a formula. And this is a formula you're probably going to use a lot if you get into pixels array, which is you can always take the Y position, multiply it by the width of your picture, and then add to it the X position. So if it's a mouse click, like I said, the Y times the width of the picture, 256, plus the mouse, or in this case, the X, or mouse X. Okay, so what that's doing is this is finding, it's letting me enter a 2D location of something and showing me the equivalent in the 1D version. So just to be crystal clear about this, in this example of this 25 pixel grid, if I were to click on pixel number 6, okay, my X position would be 0, 1. My Y position would be 0, 1. So what I really want to say is 1, because that's my Y position, mouse Y, times the width, which is 5. So 1 times 5 is 5, plus my X position, which is 1. So 5 plus 1 is 6. Okay, so that one's a little too easy. Let's do this one over here. This is, I'll do this one here, 14. This would be 5, number 5 in the X, and 3 down in the Y, right? So 5, 3, 5th in the X, 3 in the Y. So that would be 3 times, I'm sorry, this gets confusing because I always forget that you have to think of zeros, right? So 0, 1, 2, so this would be 2 in the Y, and 0, 1, 2, 3, 4, 4 in the X. So 2, 4, and 2. So mouse Y would be hitting 2, right? 2 in the Y, so 2 times 5 is 10, plus 4 in the X. 10 plus 4 is 14. And sure enough, that gets us to the 14th pixel, which is stored in this one-dimensional array, this long line. So let's see if it works over here. If this does work, when I click, I'm hoping to see a bright red pixel show up right underneath my mouse. An individual pixel is very small, so in the screen capture, this might be kind of hard to see. But look, if you look closely, yeah, there's some tiny little red dots which are showing up right underneath my mouse. Interestingly, because it's a red dot on a bright white background, it appears to be pink, and that's just kind of some color theory happening on your eyes there. If I do the red dots in a kind of orange or yellow area, it looks much more bright red, if you will, or cherry red. Okay, so what does that tell me? That tells me this works. Now, to make this much cooler, to take this one more level, right, and this is going to be the end of this tutorial before we go into the advanced version, is I now know how to grab a color underneath my mouse. Ooh, okay, wait a minute, this is good. What if I were to create a new color? Okay, so color, I'm going to call this, choice, color choice, equals the pixel underneath where I just clicked, right? I just kind of figured out this Y times the width of the picture plus X. Okay, so now I'm creating a new color called choice, and it's being set to wherever I just clicked. Instead of resetting pixels to be that color, what I really want to do is set the fill color. Okay, so I'm going to set the fill color of a shape that I'm going to be drawn to choice. It's going to set it to wherever I just clicked in the pixel array. Okay, so that's good. And then below that, what if I just were to draw this as an ellipse? The ellipse is happening at mouse X and mouse Y. I'll make the ellipse 20 by 20. Okay, and just to make sure we're kind of crystal clear, I've got all my pixel stuff. I've loaded in the pixels of the picture that I drew once in void setup. And now in void mouse pressed, I'm simply grabbing and making a new color, setting it to whatever color was underneath my mouse's position in the pixels array, setting the fill to that color, drawing an ellipse at wherever my mouse had just clicked. Okay, so I click here, I get yellow. Click here, I get pink. I click here, I get dark pink, right? It just kind of looks in some ways like I'm drawing a no-filled ellipse with the black stroke. But in fact, the fill color, if you kind of look at this closely, the fill color is there. It's just adopting directly what's underneath my mouse. Now, the gotcha moment here is, guess what? We loaded the picture in, right? We loaded the pixels in. But after the pixels are loaded, we don't need the picture anymore. In other words, I could draw a background of whatever color. I can draw a background of white after my pixels were loaded. And what happens? That wipes out my picture and I just have a white background. But if I click, look what it's doing. These are colors that I've actually already saved to memory, right, in the pixels array. And so they're already there. I didn't need the picture to be in the background in order for it to grab that color and then to kind of redisplay that color in an ellipse. I'm not plucking anything from the background. I'm plucking locations on the screen and finding the equivalent of them in the pixels array. In other words, I could draw or reveal a picture if I wanted to, which is kind of nice. So instead of mouse pressed, what if I said mouse moved? Anytime I move my mouse, this thing will fire off. It's going to happen a lot more often. I could also say no stroke if I don't want the black line around the color. And let me rerun the sketch. Okay, anytime I move my mouse, I'm drawing an ellipse right now. Right now it's drawing white ellipse on a white background, so nothing too impressive. But as I bring my mouse over, look what it's doing. There's a picture that's saved in memory. Its color information is there. And if I really were patient and I kept on doing this, it would gradually reveal a very chunky, circular, elliptical version of my JPEG. Okay, you probably can start to see the folder in there. It's getting a little arty, a little, I don't know, they look like strokes, circular strokes. Okay, if you can start to see the power in that, then great, you can start to make a really interesting kind of drawing program. And of course, the resolution of those strokes is really determined on the size of the ellipse. Does it have to be ellipse? No, it could be triangle, it could be anything else. So let me just show you what I mean. If I were to make this, 6 by 6 pixels, or maybe 6 by 12 pixels, we'll make them kind of odd shapes. Okay, and now as I kind of start to do this, I've got more resolution. It's going to look more and more like the original picture, but still kind of pointillistic. And there's a kind of famous processing example called pointillize, which essentially is using this very similar idea, but it feels more magic to new programmers because it's like, wow, how is it doing that? It's drawing a picture out of dots. This is really how it's working. It's with the pixels array. Okay, so what do we know? Just to kind of super fast recap, we can load any canvas up with any image, color information. It doesn't have to be a P image. It could be a series of shapes that you make. Whatever it is, it's just colors on a screen. And by putting load pixels at any time, it's going to grab any colors that are on your canvas at that time and save them into a one-dimensional, essentially really long line of colors. And the size of that array is always going to be the width times the height. So if you have 1,000 by 1,000, then you're going to have 1,000,000 colors in that array. You can always access them by saying pixel square bracket I to grab an individual thing that will give you a color back. You can set those colors. If you want to kind of grab any pixel in the array and change its color, you can do that. Kind of like we've done right here. But if you ever do that, you have to say update pixels to see the end result. And the final thing we just talked about is once you've got a pixels array, you don't even need to draw the picture anymore or draw that screen. You could wipe it out and then just kind of have this magical color information stored away should you want to bring it back at any time. Okay, that's the end of part 1. If you have questions, let me know, but if not, hopefully this helped you get a basic, better understanding of the pixel array. Part 2 of the tutorial, we'll actually start using this for making some more algorithmic artwork. Thank you very much.